Okay, now let's talk about what you guys need to know for the test. So the review that you're looking at follows the same format as your test tomorrow. So if you can do all of this, you know exactly the types of questions you need to prepare for. You have the same references that you had on the last test, so you don't need to have any of these memorized. This graph is here if you want to use it for any of these points where you're only given coordinates. But if you don't need it, you don't need it, and it's just there. Okay, there are a couple of questions here that are just like what you had on the last test, where it's a single transformation. Here's your pre-image, do this transformation, you're done. So that's just to kind of get your head in the right space as you start the test, but also hopefully there's going to be some easy points for you. I'm going to skip over to numbers 3 and 4, which is that's the bottom of the next side. I'm not doing any of these problems, but unless you guys want to go through any of these, but hopefully just an explanation clarifies. So you are given your pre-image on the graph, and your task is to do the composition. You need to show every step of the way. So you are given, if we look at number 3, it says to reflect over y equals negative x. So for that particular problem, y equals negative x is this line right here. I mean, that's always true. And you need to reflect over that and show where that reflection ends up. That's not your final answer, but you need to show that. And then after you've reflected it, you want to take that reflection and rotate it 180 degrees around the origin. All right, so I'm going to see in the end 3 triangles. One of them that was there to begin with, one of them that was a result of the reflection, and then one of them that was a result of the rotation. Now keep in mind, you're rotating that second triangle, not the one that you started with. So are there any questions on this?
No, sir.
Okay. The third one's kind of the same thing, except there's 3 transformations. So in the end, you should have 4 total triangles. I'll mention now, and I'll remind you, I do have an answer key at the front desk. So if you want to see, make sure you're doing it right. You can double check that before you leave. All right, now I skipped number 2. I'm going to come back to that one because when I made this review, I forgot to include something on there, which you can see now. You don't have to write the points, but you should have your initial triangle ABC and the final image of it, which is A double prime, B double prime, C double prime, in those locations. So if you want to just look at the coordinates for those points, that might make your graphing of it a little bit faster. You need to have this on your page. So when you look at these triangles, what you're seeing is where you started, triangle ABC, and then after 2 transformations, where you end up at, which is triangle A double prime, B double prime, C double prime. Notice that it's double prime. That means there was another transformation that's not being shown. So if the first transformation in this composition is a 90-degree clockwise rotation, well, the first thing you're going to want to do is do that 90-degree clockwise rotation. You're starting with your triangle ABC, because that's your pre-image. Do that clockwise rotation around. Once you've done that, you might want to draw it on the graph. Then you should be able to visually check and see what is happening to go from your A prime, B prime, C prime, that intermediate step. What is the last step that's required in order to make it map onto the double prime? Does that make sense? So actually perform the first transformation, draw the triangle, and then visually determine what the second transformation was supposed to be. All you have to do is write it down in this line. So your answer on your test, I'm just going to be looking right here to see what was your transformation. You could write it as a coordinate rule. I'm fine with that. You can write it out in just plain English. I'm fine with that too. So is everyone good with that? If you have questions, let me know. But that's kind of the gist of the problem. All right. The next side, on the top left, we've got these types of problems. In a sense, it's the same sort of thing going on, except we're only looking at coordinates. You see where you started, you see where you ended. You need to determine what transformation took place. You're going to have to write both the coordinate rule and what it is in plain English. So in certain cases, you might find it easier to do the transformation in plain English first and then write the coordinate rule, or vice versa. And that's kind of individual preference here. So with this one, if we look at B, you start with JF, and you end with F negative J. So what you need to ask yourself is, how are these coordinates changing? It's not specific points like the first one is, but we can still see what's happening. Are they flipping order? Are they changing sign? One or both of them. And so just kind of ask yourself that question. And once you figure out how the coordinates are changing, then that can lead you to the correct transformation happening. All right? Does that make sense in general? All right, what's happening here in this one is you have a composition. So you're going from E negative T to T negative E. So that's going to be one transformation you have to figure out. Now for the second part, because you can see second coordinate rule, now you're going from T negative E to negative E negative T. You don't go back to the beginning. You go from the second point to the third one and figure out what that transformation is. Okay? Again, if that's not making sense, you can certainly ask questions. You can work with other people today, or, of course, talk to me, and I'll help you through that. But you have to write it both ways, both as a coordinate rule and as a just written out in plain English. So if you like writing it out in plain English first, then all you have to do is look at your reference and write down what your rule is as a result. Okay. So any questions on that before we move ahead? Okay. The part down below that, you have 3 points that are given, and you're looking for one specific final image point. That means you don't need to worry about 2 of those points that you start with. So if you look at part B right here, you have A, B, and C as points that are given, but we're only interested in B triple prime. So that means I can totally ignore A and C. All right? So I'm going to start at... I'm going to start with that point B. I'm actually going to go through a little bit of this. So I've got negative 63, negative 65 as my starting point. And the very first transformation is to translate right 8 down 17. So I know with translations, if I'm adding, or if I'm going to the right, that's positive in the x direction. So that's just negative 63 plus 8. This is one of those problems where you should show your work. If you go down 17, that's minus 17 in the y direction. So that's negative 65 minus 17. So we can do that math real quick. This is where you might want to have a calculator, but you might not need it also. Negative 63 plus 8, what is that going to be? Negative 55. Negative 65 minus 17 is... Anyone got that? Negative 65 minus 17?
48. 83.
82. Negative 82. All right, so, and I'm not saying this mockingly, but have your calculator. If it's gonna, if you're worried you're gonna make a mistake on that, just use a calculator on the test. So anyways, we can also kind of keep track of it right here. I just did this translation, so I'm going to cross it off. I've done that one. Now I need to reflect across y equals negative x. Now if I look at my coordinate rules, I know that for a reflection over y equals negative x, xy becomes what? Negative y, negative x. I don't have to do calculations on this one, but I am going to flip the coordinate order and change the sign of both of them. So negative 55, negative 82 becomes positive 82, positive 55. You guys with me on that? Okay, I'm not going to do the last part, but I'll go ahead and cross off that we did the reflection over y equals negative x. And again, you can kind of keep track of your work along the way. This is definitely the type of problem where I need you to show your work. You can get a lot of partial credit even if you get the wrong answer by showing your work. So for instance, if you do the first 2 transformations correctly and you accidentally screw up on that 90-degree clockwise rotation, then I can give you the credit for what you did for the first 2. All right? So make sure I can see that. If all you do is write your final coordinate and no work, and you get it wrong, well, you're not getting much partial credit, or any, right? So those are the basic types of problems. The third one here is a little different. If you have trouble with that, let me know. I wasn't planning on going through that one. But it's the same sort of thing as before, except with points. you need to figure out what your second transformation is based on the points that are given. Okay, the last thing I wanted to talk about is that last part. Now yours is not in color, it's printed in color up here. But you can still see it's kind of a black and white color when printed, all these photos. And the first thing right here with symmetry is, what are the types of symmetry we learned? Line, rotational, and identity. All right? So as long as you know that, we're going to have something on there about related to the types of symmetry we learned. Now for all these pictures up here, you have to consider the color. That's going to determine if there's actually a line of symmetry. So I wanted to look at this elephant picture. How many lines of symmetry do we have?
0.
It's 0 because of the colors.
So colors do matter.
Yes, colors do matter. If I reflect this, then all the darker colors, that black on your page, is going to be white, and all the white's going to be black. So it's not the same image if we reflect over that line. So there are 0 lines of symmetry in this. But how much rotational do we have? 1. You always have at least 1. And that's all this one has. Okay, I should point out for F right here, this caused some confusion earlier. Don't focus on this rectangle shape. I wanted you to focus on the structure inside. So imagine that structure just expanded forever. Try and find the amount of symmetry in that. Okay?
So even if one side has 5 repeats and the other side has 4, don't count that?
Right. Imagine that this is a structure that kind of expands infinitely far. So I wanted you to look at the overall pattern. Okay. The last little bit that I needed to talk about. Again, down here, color matters, so keep that in mind when you're looking at that one. But these two, you did this on a handout. You have to shade in 2 boxes and make sure you meet the criteria here. So in this one, we're trying to get 2 diagonal lines of symmetry and 2 rotational symmetries. If you already did this on that handout, then you can just look at the work you've already done. But if you haven't done that yet, you just need to shade in 2 boxes. This is not a correct answer. But with 2 boxes, you should be able to match that criteria. Now this one doesn't work because I only have 1 line of symmetry right there. If I tried to go vertical, that's not going to map onto itself with a vertical line of symmetry, or horizontal, or that way. So you need to figure out which 2 boxes will make you meet that criteria. There are multiple answers, so when you check the answer key up here, if yours doesn't match perfectly, you can double check with me to make sure it still works. Yeah? All right. So you guys have the rest of the class period in order to work on this. And let me know if you have questions. The answer key's at the front. Final reminder on that.